Measuring and location technology from SebaKMT. Water leak location. Sebalog Corr. Multifunctional system for water leak location. System makeup. 8 sensors. Log-RI radio interface for bidirectional communication with the sensors. GPS aerial for easy site plan generation. Headphones for playing the recorded leak noise. Tablet PC or laptop. Angle adapter for setting the sensors out in shallow shafts. Three-point foot adapter for using the sensors in pinpointing. Configuration of the sensors. Programming using a tablet PC. We program the sensors before setting them out with the help of a tablet PC with connected radio interface. Multi-correlation. Setting out the sensors. When programming the sensors, we choose between night measurement and immediate measurement and select a time period before the start of the measurement. The sensors are set out at the individually selected measurement points. At the same time, we record the GPS positions of the sensor set points using a tablet PC. Collecting the sensors, reading and analyzing the recorded measured data. After collecting the sensors upon completion of the measurement intervals, we load the measured data recorded by the sensors onto the tablet PC via the radio interface. Using the recorded GPS coordinates of the sensor set points, we can easily generate a site plan with just one click. If we do not have any internet connection available at the moment, only the logger position is displayed without a map. Then we can enter the pipe parameters of the individual pipe sections, the length in meters, pipe material and diameter. We enter the pipe parameters for all remaining pipe sections of the measured network in the same way. We select the loggers between which we want to define the pipe section by clicking the mouse and once again entering the length, pipe material and diameter. After downloading the measured data from the loggers, we initially get an overview representation of all sensor data. By means of the graphical signal representation as well as the numerical values, we can see the most significant leak noise at loggers number 5, and number 1. By clicking the mouse on the correlation icon, multi-correlation is carried out and all 28 correlation results are represented in the overview. At first glance, we can see several clear correlation results which are marked in green. By clicking on the corresponding correlation window, we get a detailed view of the correlation result. We see the distance of the leak from both sensors and, at the top, the coherence curve with the option of frequency adjustment. After activating the Show Leak function, we obtain a traffic light display of all correlation results right in the map view. By clicking on the drop symbol in the case of this result, the calculated leak location is indicated on the map as a drop. By clicking on the correlation symbol, we end up back in the detailed view of the correlation result. This way, we can visualize all significant correlation results in the map view, which enables fast identification of the leak points present. After analyzing the measured data, we were able to identify 2 leak points in this application. One in the proximity of sensor number 5 and the second 20 meters from sensor number 4. Then, Using the V-assistant function, we determined the sound velocity in the relevant pipe sections, which led to an increase in measurement accuracy. If we correlate between the sensors number 5 and 6, sensor number 5 is displayed as the leak point, which signifies a leak outside of the measured section. If we then correlate between sensors 5 and 1, we get a clear correlation result with the leak distance of 5 meters from sensor number 5. Leak number 2 was surveyed between sensors 3 and 4. We also see a clear correlation result and a leak distance of 20 meters from sensor number 4. The surveyed leak locations were then verified and pinpointed using the pinpoint function. Pinpointing the leak location using the unique pinpoint function. Using the pinpoint function of the Sebalog Corr system, the pre-located leak locations can be verified and pinpointed. Here the sensors are employed as ground microphones. On the screen of the tablet PC, we see the values for level, frequency and ESA in real time for each individual sensor. This function enables us to quickly identify the sensor which is closest to the leak location. In this application, we see that the fourth sensor from the left displays the highest level and frequency value and thus is located closest to the leak.